In early 2024, satellite images went viral, vast green patches spreading across what everyone captioned as the Sahara Desert. Media outlets ran with it, social media celebrated it. Climate optimists pointed to it as proof that the world's largest hot desert was reversing. You probably saw those images. You probably felt something when you did. Here's the problem. Those images were not of the Sahara. The region in the footage was not the hyper-arid desert everyone pictures when they hear that name. It was a different place entirely with a different climate, a different ecosystem, and a completely different story. While that place was genuinely doing something remarkable, the actual Sahara, the real one, the one in the headlines, was doing the opposite. So if those images were mislabeled, what were they actually showing? And what is the Sahara itself really doing right now? Those are the two questions this video is going to answer, and the real answers are older, stranger, and carry consequences that outlast any headline. To understand what actually happened in 2024, you need to know the difference between two adjacent regions that most people treat as one. The Sahara is the hyper-arid core, roughly 9 million square kilometers of rock, sand, and gravel. Annual rainfall in most of it sits below 25 millimeters. This is the place that defines the word desert in the popular imagination. Immediately to its south is a completely different region called the Sahel. It runs as a semi-arid belt from Senegal in the west all the way to Sudan in the east, roughly 5,900 kilometers across. The Sahel receives more rainfall than the Sahara, enough to support grasses, shrubs, scattered trees, and over 100 million people who farm and herd across it. It is not a desert. It is the transition zone between the desert and the tropical savanna further south. What separates these two regions is a rainfall gradient, and what controls that gradient is a single atmospheric mechanism called the Intertropical Convergence Zone, or ITCZ. This is a belt of low pressure near the equator where the trade winds from the northern and southern hemispheres meet, rise, and release rainfall. It migrates north and south with the seasons. When it moves north in the northern hemisphere summer, the Sahel gets its rains. How far north it shifts determines how much rain falls and where. The Sahara and the Sahel are governed by the same atmospheric system, but that system is currently driving them in opposite directions. That is the contradiction at the center of the story. The Sahel and the Sahara are neighbors. They share a boundary. They fall under the same broad atmospheric region. And yet, since the 1980s, satellite data has tracked them moving in opposite directions simultaneously. Here is why. The Sahel is genuinely greening. Starting from the catastrophic droughts of the 1970s and 80s, which stripped the Sahel of vegetation and displaced millions, the region has seen a consistent, measurable northward advance of plant cover over the past 4 decades. This is not a weather event or a short-term fluctuation. It is a multi-decade trend confirmed by 40 years of satellite observation from multiple independent sources. The primary driver is the ITCZ shifting slightly northward as Atlantic Ocean surface temperatures rise. More northward reach means more rainfall landing further into what was previously bare land. Vegetation follows. Roots stabilize soil holds more moisture. More moisture enables more vegetation. The feedback loop, for once, is running in a positive direction. But that same northward ITCZ shift also makes rainfall less predictable, and 2024 showed what that looks like in practice. Local land management has also played a role. Across parts of Niger, Burkina Faso, and Mali, farmers have been allowing trees and shrubs to regrow in agricultural fields rather than clearing them, a technique called farmer-managed natural regeneration. This low-cost intervention has contributed meaningfully to the satellite data showing green where there was once bare soil. The Sahara core is simultaneously expanding. The interior of the Sahara is not governed primarily by the ITCZ. It sits under a different and more dominant system. The subtropical high-pressure belt, a persistent zone of descending dry air that permanently suppresses rainfall regardless of what the ITCZ does at the margins. That system has strengthened. As global temperatures rise, the temperature gradient between the equator and the poles weakens, and the subtropical high-pressure zones expand poleward. The result is that the Sahara's southern boundary has moved approximately 100 kilometers south since 1950. The desert is encroaching on the Sahel from the north at the same time as the Sahel's vegetation is pushing back. Add to this a feedback loop specific to the desert interior. Bare, pale soil reflects solar radiation back into the atmosphere rather than absorbing it, warming the air above the surface and further suppressing the formation of rain-producing clouds. The more bare the soil, the drier the air. The drier the air, the less vegetation can establish. The feedback runs in one direction only. The edge is recovering, the heart is expanding. Both things are true. Both are happening right now, and the 2024 images only showed the edge. In 2024, an unusual atmospheric shift pushed the ITCZ further north than it typically reaches in a single season. The trigger was the transition from El Niño to La Niña conditions in the Pacific, which altered circulation patterns across much of the globe. In the Sahel and the southern fringe of the Sahara, the result was rainfall totals of 400 to 500% of normal seasonal averages. Parts of the region received in weeks what they would ordinarily expect across an entire year. This is what generated green patches visible from space. The images were real, the vegetation was real, the satellite data was not fabricated. The label was simply wrong. What the images showed was an extraordinary and temporary weather event in the Sahel, not a long-term transformation of the Sahara. But here's the part that makes the story more interesting, not less. The same atmospheric event that produced those celebrated green images killed more than 2,000 people across Chad, Sudan, and Niger. Flooding destroyed crops at harvest time. Villages built on floodplains that had not seen significant water in decades were submerged. Infrastructure built for seasonal consistency rather than extreme surges collapsed under water volumes the land could not absorb. The Sahel does not need more water, it needs reliable water. The difference between a seasonal monsoon and a sudden deluge is the difference between a harvest and a disaster. The communities that live in this region have adapted over generations to work within a specific rainfall window. A 400% anomaly sits entirely outside that window. The viral images of 2024 were, in the same moment, a spectacle of apparent abundance in a humanitarian catastrophe. The headline shows the spectacle. The people living through it experienced something else entirely. The Sahara has been completely, thoroughly green before. Not at the edges, not in patches, across the whole of it. Between roughly 10,000 and 4,000 BCE, the region that is now the world's largest hot desert was home to lakes, rivers, grasslands, and forests. Hippopotamuses lived in what is now Libya. Crocodiles swam through waterways across modern-day Algeria. The Tassili Najjar Plateau in the central Sahara contains rock paintings made by people who lived there and who painted giraffes, elephants, cattle, and humans swimming. These are not myths. They are documented in the archaeological record, the paleoclimatic data, and the geology of dried riverbeds and ancient lake beds that are now buried under sand. The civilizations that emerged during this period eventually fled south and east as the rains withdrew. Many historians believe the population pressure from that migration contributed to the rapid development of complex society along the Nile. The Green Sahara did not just fade, it ended, and when it did, it pushed people somewhere. Now here's the thing that reframes the entire modern debate. The mechanism that caused the Green Sahara has nothing to do with ocean temperatures, greenhouse gases, or the ITCZ shifts being discussed today. It was driven by a completely different and far slower process: Earth's axial precession. This is a long-term wobble in the planet's rotational axes that follows a cycle of roughly 21,000 years. At specific points in that cycle, the northern hemisphere receives significantly more summer solar radiation. When that happens, the temperature difference between the land and the ocean increases dramatically. The African monsoon intensifies and pushes far deeper into the continent than it can today. The Sahara fills with water and life. That orbital clock is not responding to anything in the atmosphere. It does not care about carbon dioxide concentrations. It runs on astronomical timescales and is currently not aligned for another Green Sahara event. Based on current orbital calculations, the next time precession positions the Earth correctly for a true Saharan transformation is approximately 15,000 years from now. The Sahara can turn green. It has done so multiple times across geological history. The mechanism required is simply not available in any time frame that is relevant to any human decision being made today. Knowing all of this, what are the people actually trying to change things at the Sahara's edge is doing, and what can they realistically achieve? Two interventions are worth understanding clearly because they are often conflated and they do very different things. The Great Green Wall is a coordinated initiative involving 22 African countries designed to restore 100 million hectares of degraded land across the Sahel by 2030. Crucially, it is not an attempt to green the Sahara. It is an attempt to stabilize and extend the Sahel's existing recovery, working with the atmospheric trend rather than against it. As of 2024, roughly 30 million hectares have been restored through tree planting, soil rehabilitation, and community land management. The results in certain areas, particularly in Ethiopia and Senegal, have been significant and measurable. Communities have seen improved food security, reduced erosion, and more consistent water retention in soils. The wall's real limit is atmospheric. You can plant trees at the edge of the desert, rehabilitate degraded Sahel land, and lock in the greening trend that is already underway. But you cannot change the subtropical high-pressure belt that governs the Sahara's interior. The trees stop where the physics says they stop. The Nubian sandstone aquifer sits beneath the eastern Sahara and is one of the largest fossil water reserves on Earth, holding an estimated 150 trillion cubic meters of water. That water was deposited during the last Green Sahara period, when monsoon rains saturated the ground over thousands of years. When the Green Sahara ended around 6,000 years ago and the rains were treated, the water stayed behind, locked in porous sandstone under the desert. Libya has been extracting this water since the 1980s through the Great Man-Made River Project, a network of pipelines stretching over 4,000 kilometers that carries the ancient water north to coastal cities and agricultural land. It works. The farmland it irrigates is real and productive, but this water is not being replenished by current rainfall. It is a finite reserve, and engineers working with current extraction rates estimate it will be functionally depleted within 50 to 100 years. The last Green Sahara literally left its water underground as a legacy deposit. We are drawing that account down towards zero. Both interventions are rational responses to the situation they are addressing. Both have real, hard limits. Neither is capable of reversing the Sahara's expansion. They are, at best, strategies for managing the transition zone as it becomes more volatile. Here is where the two trends converge into a single uncomfortable picture. The Sahel greening trend is projected to continue as Atlantic sea surface temperatures rise and the ITCZ drifts further north. Broadly positive for vegetation cover, broadly negative for rainfall predictability. Modeling suggests the Sahel's northern boundary could advance a further 50 to 100 kilometers by mid-century, but the agricultural window that boundary represents will narrow as extreme events like 2024 grow more frequent. The Sahara core shows no sign of retreat. The atmospheric system governing it is not weakening. The roughly 100 million people living in that compression zone are navigating a region in genuine accelerating transition. Not toward a new Green Sahara, toward a more volatile, less predictable version of what it already is. The viral images of 2024 were not lies. They were real satellite data of real vegetation responding to real rainfall. They were just given the wrong name, which meant they told the wrong story. The actual story is harder to compress into a headline. Two adjacent regions governed by different atmospheric systems moving in opposite directions, with the people at the border between them caught in the middle. The Sahara is not turning green, the Sahel slowly and unevenly might be. and the people living at the line between them are the ones navigating what that actually means in practice. If the Sahel continues its northward greening trend for another 40 years, at what point does the line between Sahel and Sahara start to mean something different? And when that line moves, who gets to decide where the desert ends?